Alright guys, so today we're looking at complex numbers. So if you notice at first we have columns going on here. First we're reviewing what we did. We just had a quiz over and we just learned last class. So last time, we were solving for x, and what did we do to solve for x? Hold on. I gotta make sure everybody's listening because everybody needs to look up here. Earbuds out, phones away. This lesson is not very long at all, especially if I don't have to tell anybody to put their stuff away. So if y'all could do that for me right now, and then we'll be good to go. Thank you. Alright, so getting x by itself, I have to get rid of the minus 16. So I'm going to add 16 to both sides to get x squared is equal to positive 16. Everybody agree with that? Yes. Let me go zoom in a little bit more here so you can see it. Then we had to find the square root of both sides, correct? So square root, too light, gotta get a darker pen. And we get x is equal to what? Positive or negative 4. Yeah. So that's our solution. Next, so today this is what we're dealing with. That now we're having to do what with the 16? So we're going to end up with x squared is equal to negative 16 because we subtracted 16 from both sides.
But isn't that an imaginary number?
It is. You can't, so if I go through and if I put this into the calculator and I try to square root negative 16, it's like, no way, can't do it. So that's where our imaginary numbers come in. So here we go. So we're going to be using this like italic I. So we define I as equaling to the square root of negative 1. Alright, this is a real number coefficient times I is called an imaginary number. Okay? So, what is I squared? Well,
It's like x squared?
It's like, no, but we know what I is. Like x, we don't know the value of x unless we have an equation, right? But with I, we know I equals the square root of negative 1. Okay, we know the value of I. And what I want to show you is that if you if you have your calculator, so put in your calculator square root of 10 times the square root of 10. Because that essentially is square root of 10 squared is equal to that, right? Sorry. Square root of 10 squared is this, written out. Everybody understand that? So what would that equal?
5.6.
Equals 10. Square root of 10 times the square root of 10.
Oh yeah, the squared and the square root of...
They cancel each other, don't they? So these two cancel each other out. But also you can see square root of 10. So if I is equal to the square root of negative 1, and I'm asking you what I squared equals, that's just like saying square root of negative 1 squared. So what does that equal? Negative 1. Because like you said, where's my green? Oh, like you said, the squaring and the square root, they cancel each other out. So you're just left with negative 1. Alright. So we're going to put that I squared is equal to negative 1. Can you see that? Can y'all see that, or do I need to zoom in a little bit more? I also like to highlight this because we need to know this for the lesson. So we are dealing with complex numbers today, and a complex number is a linear combination of real and imaginary numbers written in the form of a plus bi. And this is the form that all of our answers are going to be in. Okay? So let's get to it. We have to review a couple of things. We have two columns here. Our first column is from Algebra 1. Our second column is our Algebra 2 column, is what we're doing today. And the reason why they're doing this is because what we're doing today is similar to what we did when you took Algebra 1 and you added, subtracted, and multiplied binomials. Remember, binomials are polynomials with two terms. Terms are separated by addition. So when I'm adding these binomials, my first binomial is the terms are 3 and 4x. The second binomial, the terms are 2 and negative 1x. Okay, that's how I know they're binomials, like two terms. All right, when we add binomials, we're just essentially combining like terms. That's it. So 3 plus 2, 5. 4x and negative 1x
3x.
plus 3x. And there we are. Easy, right? Remember when you thought that was hard in Algebra 1? Okay, so we're going to do the same thing over here, but instead of x, we have I. So again, we're going to combine our like terms. Our like terms are 3 and 2, which is 5. That didn't go away, same thing. But this time we have an I instead of x. So we can combine terms that have i's in it. So positive 4i plus a negative 1i gives me,
Positive 3i.
and isn't this in the same form as this a plus bi? They're the same form. So that's what our answers are going to look like. Okay?
So the only thing that changes is the x.
You'll see when we multiply, there's one other little thing that changes. But yes, other than that, no, because we know what I equals. I equals the square root of negative 1. That's the difference. These are complex numbers, so this is when we get a square root of a negative number. This is what happens. Take it easy. Okay, so now let's add or subtract. This is the harder one. Actually, out of everything we're doing, I think this is what's going to get y'all the most, is subtracting. And I know that sounds kind of crazy. So again, we're combining like terms. I'm going to underline my like terms here. But listen how I say it. 3 minus 2. That equals what? 1.
5.
Now, positive 4x minus a negative 1x.
Wouldn't the negative counteract the minus and turn into a positive?
And you get 5x.
Yeah.
But notice I had to say it like that because think about it. If you didn't hear it the way I said it, you may not have put that, right? You would have just gone, oh, 4 minus 1, and then given me 3x. Does that make sense? So you have to say 4x minus negative 1x, right? Let's do that same thing over here with my complex numbers. So I have 3 minus 2 is still 1, and 4 minus a negative I is going to be plus 5i. I know you're going, okay, how is this difficult? Well, it's not really. So let's multiply. Do y'all remember how to multiply binomials? FOIL. There's FOIL, that's first, add, or inner, last. Some of you may have learned how to do the box. I'm not going to do the box. Some of you may have learned how to do it using, or just saying, oh, we're just doing the distributive property twice. That's essentially what FOIL is. You're using the distributive property twice. Remember, the distributive property is taking a factor and multiplying it to the two terms inside the parentheses. Okay? So let's do that. So I'm going to take 3. So it's going to be 3 times 2, which is 6. 3 times negative x, negative 1x.
Square.
Negative 3x, right? Okay, this is a good one. Alright, now I'm going to do the same thing but with the 4x. So 4x times 2 plus 8x, 4x times negative x, negative 1x. 4x squared. X times x is x squared. Okay? So I'm not done yet. I have to combine my like terms. They're usually in the middle here. So I have 6 plus 5x minus 4x squared. Why can I not combine the 5x and the negative 4x squared?
Because the square.
Yes. So like terms have to have the same variable with the exact same exponent. And these have the same variable but not the same exponent. All right, very good. So we're done. Now you're going to notice when we do this over here with the complex numbers, we're going to be able to take another step because we know what I is, right? Here we go. So I'm going to go ahead and multiply the binomials. 3 times 2 is 6. 3 times negative 1i is negative 3i. And then 4i times 2 is positive 8i. And 4i times negative 1i.
4i.
Negative 4i squared. Nope, it's 4. 4 times 1 is 4. Positive times a negative is a negative. We're multiplying, we're not adding.
I see where it's going.
Yeah, we're not adding. This is all multiplication right now. And I times I is I squared. Alright, so let's combine our like terms. So we get plus 5i minus 4, but oh, wait a minute. Don't we know what I squared equals? Equals negative 1. Didn't we say that up here?
Yeah.
So we're going to replace I squared with negative 1. Right? So I'm replacing this I squared here with negative 1.
I'm going to simplify that.
We got to keep going. Like I said, we're actually going to have one more step. So now we have 6 plus 5i, and what's negative 4 times negative 1? Positive 4. And now we have like terms again, don't we?
Yeah.
So now we're going to have 6 plus 4 is, and then bring the plus 5i. Still keeping this form up here. So that's the difference. Okay, so like I said, I think for the most part, subtracting might give you the most trouble. But that's essentially the lesson of today. Let's go through 1 through 4 fairly fast because those aren't too difficult. So we have 17 minus 9, which is 8. And then negative 6i minus positive 10i.
Ooh. That would be a negative 16. Negative 16i.
Because we're subtracting, we have a negative number and we're subtracting a positive number from it. So it gives us, we just kind of add them and keep the sign. Alright. Here we go. Example 2. We're adding, so it's a lot easier here, right? When we combine like terms. So we have 16 and negative 8. 8. And 17i plus negative 12i.
Positive 5.
Very good. Alright, adding again, negative 7 plus, and by the way, before we go any further, because I noticed this with some people, how do you know when you're subtracting versus adding? Or,
In the first place.
Well, if
Oh,
between
if between it's positive.
it's in between the binomials, right? So it's in between the closed and the open parenthesis, right? That's how we know that we're adding here, we're subtracting here. But then look at example 5. There's nothing in between.
But they're multiplying.
So now we're multiplying, okay? I know you're like, Miss Sullivan, you really didn't need to say that, but believe it or not, I do sometimes. Because there's a lot going on here. And sometimes I look at things a lot differently than you guys do. So I need to let you know where am I finding out what operation I'm using, adding, subtracting, or multiplying. It's in between the closed parenthesis and the next open one, okay? All right, let's continue. So negative 7 plus 5. 2. Positive 2i plus negative 11i. It's not square because we're adding, subtracting, we don't square it. Only when you multiply, okay? So that's good you asked. All right, 18 minus 2. Positive 27i minus a positive 3i. 24i. All right, you good? All right, so multiplying. I feel like this is the one we need a little bit more practice with. So here we go again. 4 times 3. 4 times negative 10i. Now I'm going to the 9i and do the same thing. 9i times 3. 27. I. 9i times negative 10i. Squared. That one you square it because you're multiplying an I times an I. Alright, so let's combine like terms and replace I squared with what?
negative 1.
With negative 1. So we have 12 minus 13i minus 90 times negative 1. So essentially, what is multiplying that negative 1 going to do to that last number? Because now negative 90 becomes what? Positive 90.
Aren't you timing it by a negative 1?
Yeah, that's what I'm saying. So it's just going to make it its opposite. And so our final answer, we're going to combine 12, positive 12 and positive 90, which gives us 102 minus 13i. Make sense? So essentially all that negative 1 is doing is going to change that third number to its opposite. Like it did up here. Like up here we had a negative 4, now it became plus 4 because we multiplied it by negative 1. Let's do that again. 2 times 8. 2 times negative I. Negative 3i times 8. Negative 24i. Negative 3i times negative 1i. Squared. Positive 3i squared. Okay, we're going to combine our like terms. So we have negative 26i in the middle now, plus 3 times negative 1. So I have 16 minus 26i minus 3. Combine these like terms, and I end up getting 13 minus 26i. Good?
A little fast, but yeah.
right, what are we doing on number 7?
Ooh, remote.
Just distributing property, just distributive property. We're distributing that 7i to these two terms inside the parentheses.
So,
Won't that multiply the 7? Right?
Yeah? And then
Minus 70i squared.
so we have 21i, and I'm going to replace that I squared with -1. So we end up having 21i
Minus.
plus 70. But look at the form. And what form does it need to be in? The a plus bi. So my imaginary number has to be second in my answer, not first. So I need to change that to what? Okay, 70 is positive, so it's 70, and then 21i is also positive, so I'm going to put plus 21i. And that's my answer. Okay, I would like you to do number 8 on your own. I'm going to put the answer. I'm going to put the answer down. So you know what you're supposed to get. So here's your answer. But I want you to work the problem to see if this is the answer you get. Does that make sense?
There's the multiplying one, right?
Yeah, because look at the between the parentheses there. There's nothing.
Just wanted to be sure.
Yep.
Question: if you have two i's near the end, do you just combine those together? Like, or
When you're
do you-
multiplying?
Or do you combine it with the other one? The first one?
Let me come look.
Is 12 times 4i. 12 times 4 is 48. I times I is...
Oh, I squared.
That's what I thought you did.
Okay, so you just combined it with the first one because it's not I squared.
It's always going to be I squared when you multiply.
It's not only just combining one right here.
You only combine the ones in the middle. So you only should be able to combine the ones in the middle. Okay. Get it? All the steps? Right. Yes. Two goes together instead of multiplying. That should be 48 I squared. That's fine.
Yeah, be careful on these because I see this happen often where people start adding these together instead of multiplying when you're doing this process. I am going to go over a couple of a problem on your homework. So if you can get your assignment packet out, I want to go over. There's three of them on there that we didn't go over, and I don't want you to be shocked like when you get the answer. So if y'all could get that out for me.
the homework assignment from yesterday,
Huh?
are you gonna
Oh, me working out the homework, like the key? I can. I can post, so I'll take pictures of them and I'll just I'll put them like all in one thing. Alright. Bless you. Okay, so. How did everybody do on this? Any questions? Any questions? You're good to go? Okay. So let's look at the assignments. We're going to look at number 7 and number 10. 7 and 10. 7 and number 10.
On the homework project?
Uh-huh. Yeah, we're on the next page. We're on the back of the first. Where it says complex numbers at the top.
Oh, I thought you were talking about from yesterday.
Okay, so number 7 and number 10 are multiplying, and we know this because in between the parentheses, there's nothing, yeah, on both of them. All right, so let's start with number 7, and let's go ahead and multiply. 1 times 6 is 6. 1 times 3i is positive 3i. And then go on to the next. We have 2i times 6 is a positive 12i. And 2i times 3i is a positive 6 squared. Very good. Let's combine our like terms and replace that I squared with a negative 1. And then we have 6 plus 15i is 6 plus 15i minus 6 now. Yes, we're going to combine our like terms. What is 6 minus 6?
0.
They cancel out, don't they?
Yeah.
So your answer is just 15i. So that's, because I know when that happens sometimes, you guys think, I did something wrong. But you didn't, okay? So let's look at 10. It's going to be similar to that, okay? So 7 times 7 is?
47? 49.
7 times 7 is 49. 7 times negative 1i is negative 7i. I times 7 is positive 7i. And I times negative I is negative I squared. A lot of i's. I know.
That's kind of weird.
Okay, so we're going to combine our like terms and then change I squared to a negative 1. So 49, what happens to negative 7i plus 7i? They too cancel out. Then we have minus negative 1. Look how I wrote that.
Turned it positive. Okay.
Yeah, so now it becomes 49 plus 1, which is what, guys? 50. Do you see when I substituted for I kept the minus and I put negative 1 in parentheses because I'm substituting just for I, not for negative I squared. All right, so that will help you. Number 10 should help you with number 13 and 12, or number 11 and 12, sorry. And I think this is the only one that's going to look like this, okay? And the key is up here as well. And that's all, guys. You have the rest of class, so 20 minutes to work on your assignment. And we will have a quiz next time.
On next?
Next class on this.